1 plus 1 is definitely 2, and if you multiply 2 with 2, you always get a 4. The area of a square with the side of 4 is going to be 16, and the volume of a cube with the side of 5 will always be equal to 125. Math is certain and predictable, but that doesn't really work in the real world. Let's say, how certain are you that I'm going to land on tail when I toss a coin? Or landing on a 2 when I roll a dice? Or maybe picking a queen from a deck of cards randomly? We cannot be certain when it comes to the result of these stuff because everything is done randomly, but there are a few things that we know for sure. It's like, for example, when flipping a coin, the result or the outcome is definitely going to either be head or tail. There are 2 faces in the coin, which means the probability of landing on head is 1 over 2. The same as head, the probability of getting tail is also 1 over 2. For example, I flip this coin and I get head. That means the favorable outcome is head. So I have a dice and I'm going to roll it and I got a 6. So I want you to identify the possible outcomes of rolling a dice. I want you to work out the probability of landing on a 1. And from the dice roll I did earlier, what was the favorable outcome? You can pause the video if you still want to think. The correct answer for the possible outcomes was 1, 2, 3, 4, 5, and 6. And the probability of landing on 1 is 1 per 6. And the favorable outcome of the dice roll I did earlier was 6 because it landed on 6. So the verbal explanation or definition of the keywords I just mentioned earlier. First keyword was possible outcome, which is all the result that could occur during a probability event. Second is favorable outcome, a successful result in a probability event. And lastly is probability, which is the likelihood or chance of an event occurring. The formula of probability is number of favorable outcome per number of possible outcome. Example, rolling a 1 on a die, and 1 here only appear once, and there are 6 possible outcomes, so the probability is going to be 1 over 6. And sure, you can write any probability in the form of percentage, fraction, or decimal. But one thing for sure about probability is that it is measured on the scale of 0 to 1. Second thing to remember is the probability of all events in a sample space adds up to 1. Those were the fundamentals knowledge about probability. Right now we're going to talk about the and or rule of probability. This examination such as IGCSE, most probability questions are in the form of story problems, which means understanding this rule is very essential. So the basic theory is whenever you were asked for the probability of something and something, you times the probability together. If you were asked the probability of something or something, you add those probabilities together. Example of AND rule. So here I have 2 dice, and what is the probability of me getting a 3 in the first and 2 in the second one? So the probability of me getting a 3 is 1 over 6. Getting a 2 is also 1 over 6. Because it is AND, you multiply the number together. Therefore, you'll get 1 over 36. When it comes to doing AND rules, the final probability will always be smaller than the value of the initial one because there are more restrictions and conditions to follow when it comes to the AND rule. When there's a question with the OR rule, you plus the number together. For example, the probability of me getting a 1 or 4. The probability of getting a 1 is 1 over 6. And 4 is also 1 per 6. Because it is OR, you add the number together. Then you'll get a 2 over 6 or 1/3 in the simplified form. In the case I just talked about, it's giving us more favorable outcomes. Final probability will definitely be bigger than the initial one. So that is mostly everything about the and or rule. So let's try doing a few practice questions together. For testing your understanding, let's do a few questions about probability. Amelia is using a spinner that has outcomes and probabilities as shown in the table below. The outcomes are blue, yellow, green, red, and purple. In question A, we were asked to complete the table. Here we are given the information that the probability of spinning a blue is twice the probability of spinning a red. Let's say the probability of spinning a red is x, which makes the probability of spinning a blue 2x. The probability of all the events in a sample space adds up to 1. So here we're going to add the probability of blue, yellow, green, red, and purple and equal it to 1. Using the basic algebra theory, you can calculate that x is equal to 0.1, which means the probability of red is 0.1 and the probability of blue is 0.2 because it is 2 times red. On to the next question. Amelia spins the spinner twice. Work out the probability she gets a yellow on the first spin and a green on the second spin. Here I have written down the probability of yellow and green. And our keyword here is AND, which means we should multiply the probabilities. 0.2 multiplied with 0.1, you'll get 0.02. Last question of this section. Amelia spins the spinner 150 times. Find an estimate for the number of times the spinning lands on purple or yellow. I have noted down the probability of purple and yellow here. In this case, our keyword is or, which means we should add the probability. So 0.2 plus 0.4 is equal to 0.6. Because Amelia spins the spinner 150 times, you multiply that number with the probability you get earlier, which is how you get 90, the final answer. The last practice question is probability tree diagrams, which is actually very simple. In a box, there are 7 red cards and 3 blue cards. A card is drawn at random for the box and it is not replaced, which means if a card is drawn, it will not be put back into the box again. First and foremost, let's fill in this blank right here. The total number of cards of red and blue is 10, which means the probability of drawing a blue card is 3 over 10. Moving on, let's fill in this one. So because a card is taken out, it's not put in back again, then now the total cards become 9. First, the red card was picked, so the probability of getting a second card colored red is going to be 6 over 9. And because blue was not picked out, so the number of blue cards in the box is still 3, so it's 3 over 9. And then you do it the same way for the next few blanks. Last question of the day, work out the probability that the 2 cards are of different colors, which means 2 cards are not going to be in the same color. Either first one is blue and second one is red, or vice versa. When you have the tree diagram, it is better to see the diagram because it's going to be easier. So we're going to work out red and blue and red. The trick that I use if I do not understand if I should use multiplication or addition when doing this probability is that I remember if the probability is aligned horizontally, then you multiply the number. But if vertically, then you add the number together. Here, the probability of drawing a red-blue is going to be equal to 21 over 90, and blue-red is also 21 over 90. Then, the ultimate step, since the probability of red-blue and blue-red is vertically aligned, you add the number together. And then you get the fraction 7.15 simplified. And do not forget to simplify it. That's it. Thank you for listening to this educational video about probability. I hope it's helpful and God bless you.